Okay, we're going to be going through orbital notation. This is the last set of the electron configuration. So let's go ahead. I'm going to do kind of an easy one first. So we're going to do calcium. And we are doing the orbital notation of neutral atoms. So if I have an element number of this will be my protons. And this would be my electron since it's a neutral atom. Now you'll notice I'm not using the neutrons. I'm not worried about that because I'm doing it with my electrons. I'm not worried about the neutrons. Electrons are on the outer part, and I'm actually going to show how they're represented in orbital notation. First of all, we have to do the electron configuration for it. Now if I look at my periodic table, that shows it. Calcium is 4s2. So we're going to go up to 4s2. 1s2, 2s2, 2p6, 3s2, 3p6. That would be my full electron configuration for calcium. Now if I want to do the noble gas configuration, again, kind of going back through that again, I look for my highest P6. And then all I have to do is match up 3p6 to the periodic table. That's your noble gas. My noble gas is argon, and these are my leftovers, which I only have one of. So that's what it's going to look like for the noble gas configuration. Now if I want to do my dot diagram, my dot diagram is going to be Ca, and my highest energy level, which is the 4, would be the fourth row, has 2 dots. And my valence electrons are now the same thing. How many dots did I draw? 2. Valence electrons? 2. Let's go ahead and erase this because now we're going to do something called orbital notation. And we have to do it for that whole thing. As far as orbitals, they can hold 0, 1, or 2 electrons. What that means is when I have an orbital or a set of orbitals, I can have nothing in it, I can have 1 in it, and I can have 2 in it. So I'm going to kind of show you that. The number of orbitals I have with each one, and I'm going to just look at my S's, P's, D's, and F. Well, let's go number of electrons first. I'll put this over here. I'm going to just split it up. Okay, so the maximum I can hold with my S's is 2. Now all I have to do is split it in half for my orbitals. So let's do divided by 2. Higher level math, 1. So we're just going to divide by 2. What's the maximum I can hold with P? Now when you're doing electron configuration, and I was going on, my P's, the highest one was a 6. What's 6 divided by 2? 3. If you notice, I just repeat. It's the same thing. That's why we call it a trend, because we do all the same thing. B can hold 10 electrons, so if you notice, we went through the middle part, remembering that it runs out of sequence from 4 to energy level 3. What is 10 divided by 2? 5. So basically, you don't really need this one on the right-hand side. That's a distractor. So basically, I'm adding 4 here, I'm adding 2 here. Let's divide this one by 2. And we got F, which can hold 14 electrons. So when we go to the bottom, you're going to notice the maximum that can have is 14. What's 14 divided by 2? 7. So it's another plus 4 plus 2. It follows a trend. So I did mention on another video that you can have things like GHI. So that's kind of It's actually theoretical chemistry, but if I follow the same trend, it's kind of easy. And the bottom one, if I go on, same trend. Add 4, add 2, from going from SPDF, GHI. So again, it follows a pattern. The part I'm going to look at is this 1, 3, and 5. I'm not going to go beyond it, even though everything's all the same. So now orbitals S, P, D. Now it doesn't really matter how the orbitals are drawn. Some people do boxes, some of them look kind of confusing, but again, it's the same setup. Sometimes they put the orbitals up here. Again, same setup. I do it like this. So basically, every time I see an S, I draw a line. Every time I see a P, we have that. And then I just draw arrow up, arrow down, arrow up, arrow down, arrow up. And this is how electrons go in orbitals. You notice that I didn't just put 2 there. That's how they fill in, one at a time. 1, 1, 1, 1, 1, 1. And that's 2 electrons. The one you have to be very careful about is the last one. We do call this orbital filling diagrams. That is an orbital filling diagram. And also highest energy level is 4. That's my valence electrons, and also my dot diagram. Again, if you listen through this enough, there is a logical reason for things, and you'll find yourself getting used to doing it. Let's go ahead and do Fe, which is iron. I like doing Fe. Actually, I like doing manganese, but it'll actually show you that an orbital can hold 1 electron. So let's go ahead and do Fe. Fe is number 26, 26 protons, 26 electrons. It is a neutral atom. Again, we're still doing neutral atoms. My last one for Fe is going to be 3d6. And then you just fill in all the notations before it. 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 3d10 would normally be in there, but I have a 3d6. So that's my element. And if you add it up, then 26. If I want to do a noble gas configuration, again, kind of going back through all the stuff we have to know. Highest P6 is there. We're in the same row as calcium, not the same energy level at the end, but my brackets would be AR, and my leftovers are going to be 4s2, 3d6. If I want to do a dot diagram for this, here's my highest energy level. That's where my dot diagram comes from, because it's my highest energy level electrons, and my valence electrons equal 2. Again, watch this a few times. It will make sense. I even gave you the basics on it. Now, if you remember your orbitals for the first one, I have 1 for this, 3 for this. Again, it follows that pattern. 5 for this. Now, the last one's going to be a little different because it's kind of running in the middle. And I'll show you how to deal with that. So I got S's, same routine, P's, and then D's I have to have 5 orbitals. So So I do not pay attention to that as far as figuring out my orbitals. I go according to my set number. I can't change pattern. Then I'm going to fill in my electrons. Again, I'm showing how they fill in. And again, the most critical one is at the very end. Just imagine having to do this with like element 118. That would just be a horrible nightmare. 118 electrons, 118 arrows. Okay, so now I'm going to start filling these in, one at a time. And I stop at 6 arrows. So again, pay very close attention to your superscript. Okay? Now here's a logical way to look at this. I'm going to a picnic with the D's. I'm going to have 5 plates. I have 6 pieces of food. Let's say chicken. Well, you're not going to give 2 to the top 3 because these guys won't get anything. And you want to make everybody happy. That's the same thing as electrons. So what it's going to do is it's going to go in one at a time, and then this is going to be my 6th one. So remember when I said orbitals could hold 0, 1, or 2 electrons. These are showing my 2 electrons. These are showing my 1 electron. Hopefully, you kind of are getting the hint on what I'm doing. Let's go ahead and do another one. And this is a nice part because it kind of shows you how electrons work. They're not just, you know, do it on the periodic table and that's it. It does actually describe where your electrons go. And it's actually been proven by Mosley. So we're going to go with my electron configuration. If I find my titanium, it's number 22, you're going to see it's going to be 3D2. And it's the same routine. Even if you go to the 4th energy level and you're in the middle, you just have to add a little bit more. 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, and there's my 3d2. Noble gas configuration, highest p6 is 3p6. I'll write it on the side. That is my brackets, AR. And then I have the leftovers. 4s2, 3d2. If I'm doing the dot diagram, again I have to use the element. I don't use AR. Pi, 2 dots, highest energy level. And I have to balance electrons because my highest energy level is still 4. And it matches my dots. Again, it's the same routine as you're going through here. It's just adding something, adding something, adding something. This is your base. You have to know how to do this in order to do this, in order to do this, and knowing this. And then orbital notation is the last part. S's hold 1 orbital. Again, fill in S's, fill in P's, and then we look at this, not at this. 1, 2, 3, 4, 5. And then I do my up and down arrows. Now with the advanced ones, I'm going to tell you what these guys mean all together with orbital notation. So sometimes people prefer the easier way. Again, going in order. Going from top to bottom, same routine. Everything's all looked at the same way. Nothing unusual. There are some that are kind of out of the ordinary. You got this, and then I got those two electrons. Again, I'm not going to put the two here. I can make two people happy, so I'm just going to go like this. Now you're going to notice the difference. Each of these orbitals can hold two. These are one. Those are empty orbitals, so it's 0. That is how orbital notation works for the regular students and also for the advanced. Now with the advanced, I'm going to be showing orbital notation with quantum numbers. So it's going to kind of go in between the two.